Today we're going to be talking about mass and particle stoichiometry. So we have to remember that stoichiometry is the science of determining the relative ratios in which substances react. So we're constantly using mole ratios in a balanced chemical equation to solve our stoichiometry problems. In this case, stoichiometric problems can be expanded to solve for the number of particles in a substance. So we have to remember what we learned in the quantities unit. We remember that we learned Avogadro's constant as 6.02 times 10 to the 23, and that was either atoms, molecules, or formula units per mole, depending on if we were talking about elements, covalent compounds, or ionic compounds. So we're going to remember that as we do our conversion factors. So if we have an equation like this, so we have S8 plus 12O2 goes to 8SO3, and we are asked how many atoms of oxygen will form when 2.50 grams of S8 is reacted with excess oxygen gas. Okay, so first we're going to check and make sure that we have a balanced chemical equation. We do. It has already been balanced for us. That's always the first step, make sure that it's balanced. Then I like to organize my information. So I rewrite my balanced chemical equation and I write underneath what I have been given. So for the S8, I've been given that there's 2.50 grams. And then I am looking for the number of oxygen atoms that are being made, and that's within the SO3. So my process is going to be that I'm going to go from the 2.50 grams, I'm going to convert that to the number of moles of S8. Then I'm going to convert from the number of moles of S8 to the number of moles of SO3. Then I'm going to convert from my number of moles of SO3 to the number of molecules of SO3. And finally, once I have the number of molecules of SO3, I can find the number of oxygen atoms. So this is going to be a 1, 2, 3, 4-step problem. So I can do this in 4 separate steps. I've gone ahead and figured out the molar mass of my S8, which is 256.56 grams per mole, and the molar mass of my SO3, 80.07 grams per mole. It's a good idea to do that off to the side. I know I'm going to need those 2 molar masses because I have information about my S8 given in the question, and I'm looking for something that deals with the SO3 in the question. So those are the 2 that I found the molar mass of. So my first step is to calculate the number of moles of my S8. So I have 2.50 grams, and I'm going to use my molar mass, so 1 mole for every 256.56 grams. My grams is going to cancel, and that gives me 9.74 times 10 to the negative 3 moles of S8. Whenever I write moles, I always write of what beside it so that I don't get confused. So this is the moles of S8. My second step is to calculate my number of moles of the SO3. So now I'm using my mole ratio. I have 9.74 times 10 to the negative 3 moles of S8, and I'm going to multiply that by my ratio that there is 8 moles of SO3 in my balanced chemical equation for every 1 mole of S8. And see, this is why I like to have the species beside the mole, because then I know this is canceling out, and I'm left with 7.80 times 10 to the negative 2 moles of SO3. Once I have the moles of SO3, I'm now going to calculate step 3, which is the number of molecules of SO3. So I have 7.80 times 10 to the negative 2 moles of SO3, and I'm going to use my Avogadro's constant, 6.02 times 10 to the 23 molecules in every 1 mole of SO3. So now those cancel out, and when I punch that into my calculator, I get 4.69 times 10 to the 22 molecules. And you should calculate along and make sure that you're getting these numbers. Finally, my last step is to calculate my number of oxygen atoms, which is what the question is actually asking me to find. So I have my 4.69 times 10 to the 22 molecules, and I look at my 1 molecule, and in the formula, I can see that there are 3 atoms of oxygen in every 1 molecule of SO3. That's coming just directly from the formula, so I'm just looking here that I have 3 atoms of oxygen in every 1 molecule. So now my molecules are going to cancel, and I get my answer, which is 1.41 times 10 to the 23 oxygen atoms, and that's actually what I was looking for in the question. So that was done separately in 4 steps, step by step by step. But as I get a number from one step of the calculation, I always put in the full number into the second step, the full number into the third step, the full number into the fourth step. Even though I'm showing my correct sig figs along the way, I keep the full number in the calculator. So this would be the same thing as doing this all in one step. If I wanted to just cancel everything out all at once, I would say that I'm looking for my number of oxygen atoms, and I start with what I'm given, my 2.50 grams of my S8, and I just go through the process. So times 1 mole for every 256.56 grams, the grams cancels, and I'm left with moles of S8. That's not what I want, so I keep going. Times 8 moles of SO3 for every 1 mole of S8. So now that cancels. Now I'm left with moles of SO3. That's not what I want, so I keep going. Times 6.02 times 10 to the 23 molecules in every 1 mole of SO3. Now that cancels. I'm in molecules. That's not what I want, so I keep going. Times 3 atoms of oxygen for every 1 molecule. And now molecules cancels out, and I'm left with atoms of oxygen. That is what I want. So I can do this all in one step and just punch it in my calculator. 2.50 times 1 divided by 256.56 times 8 divided by 1 times 6.02 times 10 to 23 divided by 1 times 3 divided by 1. And lo and behold, that gives me the same exact number. 1.41 times 10 to the 23 oxygen atoms. So you can decide if you want to separate it into 4 separate steps, or however many steps there are based on the number of conversions that you see originally when you make up your plan, or if you want to just do it all in one step, but make sure that your units are canceling until you're left with the units that you were looking for.